on this little tiny single-celled animal. Well, not animals. They're called bacteria. They're not considered as animals, but they are mobile of different. Some of them are mobile, some of them are not. Bacteria, you guys should know it everywhere. They grow on your skin. You probably, once you do something like this, you have tons of bacteria falling out from your skin. There are different kinds of bacteria that live in different kinds of environments. Now, the bacteria are prokaryotes. Prokaryotes are the cell that does not have cell membrane. Doesn't have any, well, they have cell membrane, but they don't have any membrane-bound organelles. We call back to the very early time biology where organelles are their internal parts. Bacteria doesn't have that. So, there are two kinds of bacteria. There are two kinds of prokaryotes, archaea and bacteria. Now, before we go into that, there are actually three shapes for them: bacillus, coccus, and spirulina. Now, I don't know if you've ever heard of the word pneumococcus. That's the kind of bacteria that would cause infection in your lungs, causing you to cough a lot. You have a lot of them in your body of you. Different kind of bacteria within you. They have different purposes in life too. Some of the bacteria are used to make drinks. Can anyone recall? Huh? Example root beer? You know the spirulina thing? The other name for root beer? The American name. The long name. Scientific name.
No idea.
But anyway, those are used, they use the spirulina kind of bacteria to make them. Now, if you look at the scientific name of any kind of bacteria, they usually end in either one of the three terms. If they end in this term, then you know the shape of the spiral. If they end in coccus, then you know that they're spheres, and we have the same concept that applies to everything. Two kinds. Archaea are those extreme types of bacteria. They live in extreme environments, which include hot springs, like extremely salty areas, or deep, like super deep sea. Those are the ones that are archaea, and they're not common. They cannot survive under normal conditions. They can only survive during, like the ones living in hot springs. They love heat. No heat, they die. When it's too cold, they die. The ones living in salty areas, if there's no salt, you put them in fresh water. Think of salt ocean fish. Okay. Archaea, especially, the book is not focusing so much about archaea because you don't really see them that much in the world. So they're like non-common, you don't study them. But they did mention that they're usually structural different. Come to think of it, it makes sense. If they are allowed to live under extreme conditions of environment, then their structure has to be different to uphold the different types of extremism. For example, there are some bacteria that only survive under like large amount of pressure. Then you need to you can kind of logically you can guess that those kind of bacteria are actually, they probably have a very thick outside covering to hold on to their internal content by withholding the pressure from the outside. So special type of structures, you don't really have to read about them today, we'll talk about it in the book. Living in extreme conditions without that, and some of them are kind of like eukarya. What's the difference between eukarya and prokarya? Nucleus, right. Eukaryotes have nucleus. They have the cytoplasm containing their DNA information, whereas prokaryotes, they don't have any. But in our case, the category under archaea, we should actually find some of the archaea organisms that would have nucleus or look like eukaryotes. Okay, so far so good. Two types. Prokaryotes are into two sectors, archaea and bacteria. Simple. Nothing fancy in there. Now, the next part is bacteria. I draw a very simplified form of bacteria. If you don't like it and it's not explicit enough, you can actually look at your book for the picture. We have a much more proven methodology picture of the bacteria. Now, the law of flagella thing is not hard to recognize. The water thing has flagella. What is flagella used for? Movement. Usually flagella is just whip around. How can I have movement around? call stranger, glass cancer, parasites, you have a host and you have a parasite. Now, parasites, they usually feed on their host. Some of them, like, we have bacteria living inside us. Those are the ones that feed on us. Some of them are good. You guys don't downloadable, right? Downloadable is a kind of bacteria that actually it does something in your body, helps your digestive system instead of your immune system at the same time. So you can do that. Do you drink downloadable? You do, right? Or yogurt or any sort. You do. Then may I ask, how do you classify? It's actually making bacteria which is living, and then it is here. Right. So, is that a left of bacteria?
That is...
I asked you that question.
Okay, re-ask your question.
Okay, so you saw that little, right? Yeah, you want to stop them.
So yeah, little. Yeah, little is, bacteria. But my belief is that I eat things that don't have life.
Don't have life now.
So then, I just set up another thing like that. But then, if, for those who are really into your religion, they are pure vegan. Which, as for me, I go around with baseball. And, go by things. Like, for example, they say no, I don't go with it.
So, you think it's okay because you don't take it for a religious habit. Good point. I've never considered that one.
Yeah.
She has a point. That makes sense.
No, pretend I didn't say the last part. I mean,
okay, I'll take it to that. Okay, so here is structure. What's important in here? Structure is widely used in scientific research, especially related to genetics. Because they have this little round, circular DNA called plasmid. In my college time, doing research, what we have to do is extract a lot of plasmids from a specific type of bacteria. What we do is we cut the plasmid open, so imagine you have a round circle. You cut them open. Now all this round circle are actually made of DNA. What are the 4 bases of DNA? So actually a plasmid is like a circle thing with tons of bases in here. So they keep it going. Whatever, blah, blah, blah. Now what we do is we cut them open. We usually know the sequence of the part where we're cutting. We cut them open and what we do is we would put maybe virus DNA into it, or maybe human DNA into it. And then we fit it right into the opening of it. So this is like the internal DNA. Okay, so that's what we do. We use this as a transporter, transporting human DNA, and then we inject it back to bacteria. And then we see how bacteria will process this protein. Usually a section of DNA that we're inserting, or usually a section of